Ian Comishin is the president of Twente Additive Manufacturing. And again, I am running out of internet B-roll of the Netherlands. So I don't know, here's some tulip fields or something like that. We've got a very interesting background from Ian. You know, he has a deep background in automation, but Ian and one of the founders of Twente Additive Manufacturing actually started using CNCs to build skateboards before anyone really adopted it at an industry level. And that company is now in its 30th year of operations. But as we look to industry, he's also a gentleman who has worked in wind energy by building the automation for making wind turbine blades. That business grew into to really kind of corner the market, with 90% of the companies worldwide using their machinery to enhance production, eventually building systems for airplane wings like 787 prototypes and the like. This group of people, including, of course, Ian, has turned their attention to the 3D printed housing market, and they've got some incredible offerings through their work. I want to welcome to the stage Ian Comishin, who's going to be sharing his camera now. Go ahead and turn that on, Ian, and we'll get you set up. I'm going to add you as replace you as spotlight. Ladies and gentlemen, big digital round of applause for Ian. Thank you so much for being here.
It's my pleasure, Alex and Kevin. Thanks you guys both for doing this. This has been a really cool collective of guys and women getting together to sort of bring up the challenges and opportunities around this technology. So very fortunate that you guys put the effort in to make this happen.
We're glad to have you. Ian is going to be sharing a 15-minute presentation. I'll do a 15-minute interview, which will again blend into audience Q&A. So Ian, if you'd like to, you can go ahead and share your screen, which is processing now. I can see that presentation, and let's make sure that it goes into presenting mode, which it did. With that, Ian, take it away.
Okay, great. So yeah, just real quickly, a brief background on who we are. Most recently, we were working in the wind energy space. Automation was really the entry into that market. We were building humongous parts. If you look at that blade that's on the left of your screen there, that's an 88-meter long blade. So for us to get into machines big enough for building houses is actually quite a stepping down from the grand scheme of things. And then, of course, you know, the industrial automation around aerospace and wind energy is highly advanced and very challenging different types of control systems and those sort of collaborative robotic environments. And so for us to jump into 3D printing was almost like a fresh space for us to work in a new industry that hadn't really seen you know, the state of the art really applied yet. So that's how we got to this. When we went out there, there was pretty much an industry that had already been established. You know, I'm sure all of you by now know the 6 sort of main types of 3D printers that existed, have been around for a little while. We can see strengths and weaknesses in all of these here. It's a little bit unfortunate that some of my professional colleagues came on in this presentation and decided to use derogatory language around each other's technology, because everything that everyone's doing actually has its strengths. And of course, you know, we could pick apart any piece of equipment. You know, not everything is perfect. So the notion that the tide is going to rise all boats, like came from Chris's presentation from Mighty Buildings. I really like that concept. You know, we really want to collaborate with everybody. We like the idea of you know, this technology really changing the housing industry. An anecdote that I can give that I like is last month I was in Jakarta and I met with the Ministry of Infrastructure and Housing there, and they need something like 11 million homes for their affordable housing program that they're short. So if every one of the speakers that spoke in this conference today and yesterday was able to print 100 houses a year, which they're not, we're not at that scale yet. If each one of those companies was 100 times that size, so maybe 160,000 homes per year, it would still take us almost 70 years just to satisfy the needs of that one man in that one office in Jakarta. So, you know, we don't really need to be trolling each other. We can definitely be building this industry up together, and you know, all the technologies have their strengths and weaknesses. We wanted to look really at the best of all the worlds possible. So we built our first Cartesian printer, and we built our first robotic printer. and as well all the pumping systems that had to go with that. And from there, we determined that if we really wanted to make a change, that we would come up with like a 9-axis Cartesian robot, a modular 3-axis on tracks, which some of the other companies out there are doing, such as Black Buffalo and Mudbots. They've adopted that same concept. And then we also want to do a mobile 7-axis robot. Our first 9-axis printer, the Leonardo 1, we built this in Nelson, British Columbia. One of the things that's kind of fun about this space, and I know you guys were talking earlier about, the world's first this or the world's biggest that. That's the kind of fun that we can still have in this space because everything is still so new. I think it's really cool when, one of our colleagues does the world's first something or other, because this early adoption stage we're at right now makes it so that there are hundreds, if not thousands of world's firsts about to happen. And it's the type of thing that gets the media excited about us and really puts this technology sort of at the tops of the headlines and in the feeds on people's phones. And that's really what we need to get people excited about it. So it actually turns into something mass accepted. We've got a couple of years behind us now. We've built an R&D lab in Germany. We built a subsidiary in Canada. Like I said, we built that first 9-axis printer. And then we printed live for the Big Five Dubai. In our second year of operation, we printed the first house in Canada. We built our first mobile printer. Some conversation about what a mobile printer means. And in our language, we like to refer to a mobile printer as something you can actually tow down the road. There are definitely some cool crawler systems out there that allow printers to move around on the job site, but that's the way we use the term mobile. We did a rapidly deployed building, and we printed the world's first 3D printed playground. And then just last year, we opened up a subsidiary in Dubai. We got our manufacturing established in Montreal. We printed a guardhouse for the UAE Ministry of Justice in Dubai. And then with our partners in Japan, we co-authored a patent for concrete SIPs using non-planar strategies. I think the thing that's really got the most news attention for us has been the Fibonacci house. So what we chose to do is to try to make the most difficult house that we can imagine for ourselves in a short time frame and do it on an affordable housing budget. In this case, we used our Leonardo printer and we did everything prefab and transported the elements to site. We used a crane to lower them into position. And if you actually look, the footing, or it's actually a monolith slab, was also 3D printed. But those were also hand placed. We used a column system that used parametric design. And our technology was using both the 1K and 2K systems you've heard some of the other presenters talk about. Obviously, it's a tiny home. This was not meant to go on the open market. This was really just to prove capabilities. I think the other thing is also quite important to remind everyone is we came from an automation background. We've not come from a construction background. We've almost had to become somewhat construction experts because it was so new that there wasn't really any contractors in the region who knew how to go about dealing with this. And of course, we wanted to go through the learning experience of, messing up as we're going along, and how is working with 3D printed elements going to be easier or more difficult. One of the things that came up yesterday that I heard is that we can't print on uneven ground yet. That's actually not true. We have this system where we're taking laser scans of the topography. You can print elements that would actually go into the bedrock, can be pinned into the bedrock. And this dramatically reduces the need for, excavation equipment or dynamite. And you can design houses that really blend with the nature that's already there. We have invented a system for embedding fiberglass in, quite similar to what they did at TU Eindhoven with the wire. However, in this case, there's a continuous roving of fiberglass. So this helps dramatically to increase the tensile properties of the concrete, which most people know is not notorious for being very strong in tension. And then we've also looked at this concept of building roofs. This is also an area that is a big question. People are constantly asking, how are you going to cover these buildings? Traditional coverings are fine, but working with Alexander Kurth or Sandy Kurth, some people call him at MIT, we came up with this really cool concept of making squinch vaults with a 3D printer and experimenting with different nozzle orientations so that you could make these forms, potentially removing 40% of the mass of a slab. So skyscrapers could be on smaller piles, or they could perhaps be 40% taller for the same mass. We built a truss beam concept. This is a very cool looking roof. It's got compound curves in it, but if the thing that's really different about this strategy is we can actually 3D print the rafter locations in. So by putting this on the roof, you've reduced the risk of a construction worker who's going to be up there trying to measure out his 16-inch centers and having to use conventional measuring equipment. He can just drop the rafters into the slot. This also actually was a combination of 3D printed material and then 3D printed infill because we wanted to put a rebar cage in afterwards. So the outside material is with the laticrete material and the inside material is almost with like a self-compacting Lafarge ductile material. And then we also did actually use fiberglass reinforcement in the bead itself so that the different shrinkage rates between those two materials wouldn't fight with each other and cause huge cracking. You can use 3D printing for water management. So here is a ford that we made for a mountain bike bridge where there's an enormous amount of swampland. We're working with Saxon University to build fish ladders to create spawning habitat. What's interesting about this is that they didn't actually use any geometry in the mathematical sense to determine what the heights and the sizes of these fish ladders would be, but rather they created an algorithm that took into consideration the flow rate of the water, the species of the fish, the sort of known heights that they like to jump in their natural environment. And then the part was created for the robot parametrically. So it's a way where the technology can actually go far beyond what conventional concrete construction is, even at the design level. We work closely with other universities. I mentioned Saxon and MIT, of course. Selkirk College, we're doing a topography optimization project. There's a really nice group of people called Citizen Robotics in Detroit who really jumped into this early. It's an offshoot of the Lawrence Technical University. They have garnered the attention of quite a few people in that region for affordable housing. University of British Columbia, we're working with them to develop a pump. So there's a very great relationship that we build with universities for a couple of reasons. One, they're really the ones pushing the acceptance of this, both at the code level, but also at the level of how the community accepts this technology. The stuff that KEIKO presented in his presentation, if you want to attend the Loughborough Rylam event, you'll have 3 days of that scientific work. It's really phenomenal, and we think that the only way we can succeed is to keep maintaining these relationships with universities to keep that knowledge. And of course, to get great resumes, right? So the reason I was invited to talk today was to focus on a printer. I could keep going on about all sorts of things we've printed, but we actually have 6 printers in our product line. So I'm just going to focus on the one that we call the TILIKUM, because it's the most unique in comparison to the other printers that have been presented here. So this is what we developed for doing on-site but mobile printing from the perspective of being able to get in and get out with quick setup. So it sort of couples a bit of a large print area. So the track itself is 20 feet long. The robot has about a 12-foot reach, but then we can also add up to 7 or 8 feet of nozzle on that. So, it's pretty easy for us to do 550, 600 square feet of printing area. The first one we built was the TILIKUM 1, and we gave it a stress test on its very first day of printing. We took it outside where there was frozen ground and pretty harsh work environment, and it works like a charm. As I'd mentioned, Citizen Robotics, they were under the fire to get some really cool prints done for the governor of Michigan, who was coming to visit them. So this is an example of the TILIKUM being used there. The Ministry of Justice in Dubai. This is a really weird project because the building had actually been started before we got there, and it was designed to be built using cinder blocks. And what had happened is they'd already had plumbing and rebar coming out of the ground. And so we had to actually figure out a tool path that would take into consideration the obstructions. And so we had to move around the different blocks in a way that would allow for us to not have the printer hook up and cause a misprint. We used that same printer about a week earlier in live presentation in a trade show where we put the 2K nozzle on, and actually everything you see there was printed in an environment where we had hundreds, sometimes thousands of people passing by the booth, watching us as we printed live. The thing that's really interesting about the TILIKUM is that it is fast setup. It is quite a large print volume. So that print you're looking at there, it's for an affordable housing project. It's just a tool room, but it is in a very rough environment. And that was done in one setup. So you can see that there's a fair amount of print space that you can accomplish with a 7-axis machine. You can use it for doing really cool slab prints. In this case, this is an artist from the Haida community in Canada who drew this Thunderbird. And we use the print to use dams. Basically, it's a damming system where we can put different colored concretes, conventional concretes in between to make a really nice aesthetic look. But you know, the real point of this conversation is, can this technology be used for housing? Of course, we have our other printers that are much bigger. They're obviously much more set up for large prints and doing housing. But the notion of rapidly deployed and being able to get in and get out quickly makes the TILIKUM a really interesting machine for designing houses specifically for rapid deployment. And in this case, the printer itself will actually only be set up one time. And this entire 550 square foot home will be printed. We figure it should be done in about 12 hours, but you know, we're saying two days just for, just so we don't overpromise. They're structurally resilient buildings. They've got 2 walls. In order for them to be approved in some jurisdictions, we are putting in a post and beam strategy. Really doesn't take an enormous amount of manpower or person power, pardon me. 2 operators can run this, and most of the time they're sitting there looking at their phones and talking to their buddies and checking to make sure that the pump is being properly fed. So I think from this image here, you can see kind of how it's set up. The concept is to have a window wall or a curtain wall on one side so that the printer can be pulled out. It's a little bit wider than an average door. So from that perspective, you have to have some other type of frame that goes in there. In this case, we chose glass. But it's not impossible to, pull the printer out and print that final wall in if you wanted to. In this case, we're just trying to do a single setup concept. The roofing system can be whatever. In this project that we'll be doing coming up, we're going to be using cross-laminated timber. You can use rafters, you can use conventional trusses, or if you're feeling experimental, we can do the MIT style slabs or other 3D printed versions. Next year, hopefully, we'll be starting to deliver our first 8-axis TILIKUM. This configuration, we should be able to do 2-story buildings. The X that you see there, the scissor lift, is actually an indexing motion. So all of your Z movements while you're printing will still come from the robot. It's got incredible range. And so the scissor lift itself will just be for moving from, 3 feet off the ground to 6 feet off the ground to 9 feet off the ground, that type of thing. Yeah, so I guess that kind of wraps up the conversation around the TILIKUM X. The idea of this presentation, the way it was asked by Alex and Kevin, was to sort of focus on one of our printers. But to be honest, our modus operandi at Twente has really been to push as much as we can technology into areas where people haven't imagined yet. You look outside any city, any urban area, and you'll see that virtually everything has some sort of concrete component to it. And 3D printing can play a role in any of that. And that's why we have so many different types of machines, because the application case for one customer will be completely different than the application case for another customer. So, and everybody who spoke here, they're selling machines faster than they can make them. There's lots and lots of room for people to join the industry. And we love the arms race that we see going on right now. So it's really in this industry.
Awesome. Ian, thank you so much for that presentation. Obviously, we still got a half hour with Ian to ask him a lot of questions. The first thing is, I think there's something about this conference that is scaring our presenters off and making them shave their beards. Because we had another one yesterday with the same thing. I'm jealous of you guys. I'm from the part of Asia that apparently doesn't grow much facial hair. And then also, I think I misspoke literally like a word or two. I meant to say that Twente Additive Manufacturing I believe is headquartered in the Netherlands, but of course has operations.
Yeah.
And you're based in Canada, correct?
Well, I am Canadian. The company was founded in the Netherlands, and we probably would be a little bit less Canadian centric if it hadn't been for COVID. But I was stuck in Canada that whole time. So right now, the Netherlands represents for us mostly administration and engineering. I think I'm like the fourth Dutch company presenting or organization presenting today alone.
Yes.
Reason for that, we've got an awesome engineer from Saxion, another one from the Amsterdam Applied Sciences University, our digital designer from architectural schools, studied at University of Delft. It's a community that seems to have embraced 3D printing a little bit faster than the rest of the world, and so we have access to phenomenal talent pool there. But that's not to say that things in Canada aren't going well either. There's some really great talent coming out of the schools in Canada, and as you saw, like University of Purdue and USC Berkeley, MIT, they've all got great 3D printing programs as well. So.
Yes, and in honor of that, I'll throw this animation up as we get into questions from me from an interview perspective, but also, of course, from the audience. And so let's kind of get started. A lot of questions have centered around that lead time to get the printer in my hand. So I'm going to ask that question to you with Twente Additive Manufacturing. How long does that take? And then, John's question that just came up in the chat, is it lease, is it purchase? Thoughts there?
Yeah. So it's pretty specific to the type of printer that we're making. The printer I presented there, the TILIKUM, we are beholden to the robot supplier. We do work with ABB, but not exclusively. For example, our printer in Germany is on a KEIKO. Some of our clients are comfortable with using refurbished robots, so we can go to the open secondhand robot market. But right now, unfortunately, turnaround time from ABB for a new robot is about 26 weeks. And so that's what we're telling people for our lead times, because the rest of the components we can bang out in under 5 weeks. So we're really just waiting on those robots to be available.
Mm-hmm. Yeah, it makes a lot of sense. And here's the thing, for anybody discouraged by these supply chain challenges and timelines, if you've never printed like a building, go visit something, right? Get some training. I mean, it takes time to learn all of these things, and you don't necessarily need to own the robot. In the example of Cobot, like we sent somebody down there and just to check it out, evaluate the machine. And I'm sure there are opportunities with Twente Additive Manufacturing and all the vendors to get educated before it touches your hand anyways. So you may need that time, right?
Yeah. Well, the other thing too is, once we hit critical mass and we're in a financial position to carry inventory, that's different. Right now, we're doing just-in-time manufacturing, and that's because this is still a space where we're trying to overcome conservatism. In the lunch networking, we heard a lot of conversation about whether or not curvy walls or sausage bead walls were going to be accepted readily by the open market, and that's for sure a concern. I guess the notion that we're trying to get across in the projects we're doing on here is that it's not costing extra to have these advanced features. So it's really just to spark the imagination of who's going to be working with these things. If we can do something difficult, then obviously doing something easy is within the realm.
Yeah. And I do that, this comparison a lot with just intro conversations with folks, whether it's in construction, investors, et cetera. I say, okay, if I printed this piece of paper, just, like print a piece of paper, copier kind of thing. And I press this button to print this, whether this says just a set of words here, or it prints full 4-color and all this complexity, there's literally no difference to me right now. No. That's not true yet in, of course, 3D printed construction, but that goes back to the opening address that Kevin gave, which is this, like the unpairing of cost and complexity is kind of hard for us, for people who are just stepping into the conversation. But I think, Ian, it speaks to a little bit of what you were saying. It's like, well, if it doesn't cost anymore, then there's features, that's okay, but you almost have to argue it sometimes.
Sure, but the thing is, so we are not builders. What we're showing is that, coming from this with a bit of whimsical creativity, we're doing all sorts of elaborate things. The complexity that you're talking about would be, how is MEP going to be dealt with? How is your interface components between your windows and doors? These are areas where the machine can be taught to deal with this stuff. And that's where the cost savings are really going to start happening in an affordable housing project. The notion that it needs to be more expensive because it's complex is going away, as you say.
Yeah. And any additional thoughts on how to finish MEP that you've kind of seen in the field? Obviously, like you said, you came from a technology background, but you're obviously interfacing with folks who are building these houses, things that they've brought up that are kind of behind the scenes. Any thoughts there?
Of course. Yeah. Well, look, I'll be honest with you. We're hoping that 3D printing is the gateway drug for the automation of the entire construction industry. We see robotic placement of plumbing coming, robotic placement of electrical coming. This is not like a far reach in this space. As you saw, X3 was putting windows in their prints. This is going to be very easy. We have milling capabilities already on our printer. So we're doing a project with a company in Japan that there's a bunch of compound curves and there's foam between those curves. And we were able to just take the printer head off and put the milling head on and carve out the elements that need to be carved out. And then we just went back and printed the next layer down. So that side of what needs to be accomplished is actually not really a far reach. One of the things that John said yesterday that I kind of like is that we're giving each other too many high fives. There has been so many amazing automation processes that have been accomplished in so many other industries. The construction industry is really coming on very late in this space. All you have to do is, download a couple episodes of how it's made, anything related to agriculture or food management, and you'll see that the types of machines that we're making for 3D printing are kind of basic. Like, we're giving ourselves pats on the back that we've invented this crazy technology. But this is it's kind of child's play in a way. What's the biggest challenge here really is whether or not this technology is going to be something that's going to be readily accepted by a very conservative buying market, which is construction.
Yeah, it reminds me of my days working in an enterprise software company in market research and competitive intelligence. And one of the things that it was an earlier part of my career, but the thought there was like, we kind of had like a miracle technology. And it wasn't that complicated, but it like really solved a problem. But as I was just being introduced to the culture in different industries, they're like, banks and healthcare are going to adopt technology right away. And certain higher education, back office stuff, and their even government kind of can be sometimes slow, at least in the United States. And it's literally like a culture of adoption. It's not like I got the miracle, I got what you need, and I'm telling you I do. It will pay for itself. But you're absolutely right. How fast is the construction market going to adopt to this, or is it possible? Even like a Tesla, everybody says Tesla, but it's a good analogy, right? An X factor comes out of left field and says, if you're not going to adopt and change fast enough, I'll just move into this space and do it myself. I wonder what our path is in convincing the construction industry traditionally, or does this become a new space? It'll be interesting to see how that plays out.
There's an anecdote I like to give that sort of describes the state of the industry we're in right now. So we receive an enormous number of phone calls or emails, and people ask, if I buy one of your machines, how much is it going to cost for me to build a house? And it's a very strange question to ask us as machine builders, because there's like an infinite number of variables that go into building a house. It's a very complex piece of machinery, and the technology that we're providing really is just to deal with one of the elements, and that's sort of the structural integrity of the building, and maybe the finish, should that be the goal you're going for. It's almost like if you were to call up a company who makes machines that makes doorknobs and says, if I buy your doorknob making machine, how much is it going to cost me to make a house? But we've had to sort of leap into that space. And so everybody on our team, they're kind of becoming very knowledgeable in the construction field, because we sort of have a huge education path that we need to get people to come up to, and conferences like this are phenomenal for that. And we still try to help people cost out their houses. We don't just slam the phone down on them and say, look, this is not really for us to sort out. But the reality is the way you kit out a house in Ohio is not going to be the same as San Diego, never mind Japan or Chile or some of the other places we're receiving calls from. So we're trying to use the coding, like Black Buffalo seems to be very strong with their code group. We're part of the G80 that's doing the ISO ASTM standardization. There is methods around using quick calculations to see what sort of print times and print volumes. And you can give people the price of the printed element of it, but they still got to do their own research on what their local contractors are going to do. But it's not like a slam dunk. You phone up, say, I want a 1,500 square foot home, maybe 2,000. I'm not really sure how much is it going to cost if I buy one of your machines. We just can't answer that. And I'm afraid to say nobody in this space can.
Yeah. Awesome. Great thoughts. Let's get to this MEP question. Can you go into more detail about the steps taken to print around existing MEP stub outs? You gave an example with this cinder block house. Any thoughts there?
So what we did in that space, because we were using with a fairly high capacity robot, we were just able to put a very long nozzle, and that long nozzle was able to reach around those elements. Of course, if anything was running horizontal, we still would have had the problems where we'd only be able to run parallel with the horizontal runs. But anything that was sticking vertically out of the ground, we would just move the nozzle around them.
All right. And then we've got a question about any hydroelectric projects. And I'll expand this to things that are not printed walls. Any new things in the pipeline outside of what you've already done, or even just ideas or thoughts that you guys have had about what you can print more than walls?
Yeah. Okay. I'm going to do a quick share screen here, if that's okay.
Yeah. No, that's great.
Slides that we didn't get through, but let's just see if I can do this.
Nice.
So if I go on to the next page here, sorry. We are actually working on a water desalination project in Indonesia. So you can see there on the left. Again, it's dealing with some very tall columns. I'm not sure if you can see my mouse here, but they're going to have these steel I-beams that are going to be in the ground already because of the nature of the project. They need to have the roof standing before we can start printing. And so we're going to have to work around that by moving the nozzle around there. This project is for the US Air Force in Dubai. We're printing them barracks. And again, it's a really funny project because they have rebar sticking out of the ground 6.5 feet tall. And so we built a nozzle that'll actually be able to reach around that rebar, go all the way down to the ground. This TILIKUM single setup house called the KEIKO, you see there, we're going to be printing 20 of those houses this spring, hopefully getting started next month. And it's for a town that was absolutely devastated by floods. There's a big rainstorm last year. And so they want to rebuild something that'll be slightly more robust. And it's just temporary housing as the families get back to their original homes. So I think I answered maybe more questions than you asked there, but
that's all right. I like it.
Using this technology for things other than housing is absolutely going on.
Yeah. Just a question that I think a lot of people are focused on as we're growing our organizations. You hiring any for any positions, internships, partnerships? What kind of connections are you looking for?
Yeah, we're always taking resumes, of course. We set out to be just a machine builder, but we're definitely in the printing business as well. Part of the reason is it is a massive investment for somebody to jump into this space. We have clients who are taking the risk and they're going to be printing, and we will send teams out. So if you're liking traveling and you want to see the world, we're definitely putting people on airplanes to go and work with our clients all over the place. And then, of course, the types of partnerships we're looking for are obviously people ready to purchase machines. That is our principal business, but we are taking on development projects as well, like these two that you see here listed on the screen. The shared wall concept of Milokinos Heights, and then the Sakura Place affordable housing project with World Housing.
Nice. And I got a question about something that actually Twente Additive Manufacturing posted on LinkedIn. There's a question about a post that mentioned that you tested different print strategies. Is there any report or publicly available result of that?
Yeah, so the most recent testing that we did that I think should be coming out publicly would be with the University of Windsor. They are actually collaborating with a bunch of different printer manufacturers as well. So we did all of the empirical testing for the houses they're going to be building. They're actually going to be working with a company called Nidus, which has a Cobod machine, and they should be hopefully giving tensile properties, compressive properties, the water penetration and water permeation properties. But honestly, like the Canadian universities are pretty far behind what's come out publication-wise from Europe already. Definitely TU Eindhoven, they're giants in the space. The the team of students and the PhDs that have come out of Teos and Frake's group there are really good. And then we're all in awe of everything that they've done at ETH Zurich as well. Those guys have some phenomenal graduates who've done excellent publications and lots of publicly available reviews on the science behind this technology.
Awesome. Can you talk about any printing? Can you talk about printing unsupported overhang with a 2K system, or any thoughts of that?
Yeah. So a lot of the videos that we published that have become very popular are the ones that are using the 2K system, which everybody knows is a little bit more expensive than conventional 1K, but the build properties are phenomenal. It's really fun to work with that stuff. We have an awesome partnership with a company called Baumit. They've got some patented technology that works really well and a nice material. I know Volker earlier today said that there's only 4 companies that make 2K nozzles. We actually do make our own 2K nozzle. We just have not put it on the open market yet. And the notion of being able to change the ratio of accelerator right at the nozzle level dramatically changes what your building capabilities are. So this is a high-end print. It's more for architectural feats and for, like he said, like potted plants or beautiful structures that have high markup. From a housing perspective, it poses 2 problems. One, cost factor is always going to be an issue in housing just because of the sheer size of buildings. And then secondly, the more additives that go into a print mix, basically the thing that makes it cure faster, the higher ratio of shrinkage you get. So shrinkage is the cause of virtually all cracking. And even if you're designing parts like we try to, where the print is always only being used in compressive loading, cracks can still be something that aesthetically are unpleasant, or like one of the other comments I heard earlier is that it just makes people fear that they're in an unsafe place. So if you're printing things in a way that are cracking, you're not doing that 2K technology at service. So we try to stick to the high-end stuff with that one.
Awesome. Now there's a question about a video that someone saw on Jared Gross's channel, which again, we were playing a drinking game. Every time someone says Jared Gross, to take a shot. Please don't do that, you'll die. But what the question here is, what was the compound curved printed structure that was featured on Jared Gross's channel? Is it complete, and when will it be showcased?
Sure. Okay. So that was a technique that we co-invented with Serendix, a company from Japan. And they're building these glamping spheres. And what it is an incredibly complicated architectural feat that was designed by Clouds AO, a really cool architectural firm from New York. And the notion was that we wanted to build something that would be structural, yet would also have the thermal bridging capabilities that we expect in high energy environments such as Japan and Canada. What we did so far was just 4 panels. It's a 12 panel print. It was just for proof of concept. So the next one we'll be printing in Japan when they get their printer, and hopefully you'll see, I think their goal is to print 5,000 of them. So yeah, it's a fairly ambitious project that they have going on.
Awesome. And then Ed asks a question, and I'm just going to repeat it for anyone who might not have heard, but what the lead time is on deposit to delivery. Ian mentioned a 26-week lag because that robotic arm isn't manufactured by them. There's supply chain issues that are, of course, not unique to Twente Additive Manufacturing. So hopefully it gives you, Ed, some thought there. Any extra color to that? Or
our gantry printers are taking somewhere between 14 and 16 weeks to get out right now. And they are, modular in different sizes and shapes. The robotic printers can come out faster as well, should we decide to go with a refurbished robot, and we're able to find it on the open market. It's kind of a bit of a battle between Volker and us for those refurbed robots, because he's actually got the best source of them. I got to be honest. I have to look around and pick up the scraps left over that Volker didn't take, but.
That bastard.
Lots of great machines.
Just kidding. No, Volker is awesome, and you're
actually a mentor of ours. We wouldn't be where we are if he didn't invite us in and tell us what he had going on. And Barry at Seabay came and showed us. Well, we actually went and visited him, but he showed us, his vision for the organization, where it's going. And we're definitely a very small niche industry. We all keep seeing each other at all these conferences. and our collective ideas are growing the whole industry. You know, it's not you're not looking at like a Nike and Adidas and a Puma type gathering when you're talking to all these big players in the space right now, because it's so early adoption.
Yeah, co-opetition, you know, that's what they would kind of classic textbook call it back in business school. And you're absolutely right with the comments that you had, even in your speech. Obviously, everyone's kind of sharing competitive advantages. There's different approaches for different companies, different countries, different business cultures. But at the end of the day, when it comes down to it, we need to be sharing as much as reasonable, and also recognizing that we all have advantages. And if we get sort of almost like too competitive, you know, it almost like it brings down the reality or the excitement of the industry, because like, oh, well, I guess that's not viable because this person says it's not. I mean, you know, we're all kind of at a place here that we got lessons to learn. So it's good to
It doesn't
support.
make sense that you'd be sitting here and fighting over one piece of pie when there's 40 acres of blueberries and 600 acres of wheat just outside the door, you know. So, and that's really the comparison.
Yep, and Ian, in the state the industry address, you know, even in the United States, you know, focusing only on one country, we're behind 4 million, 7 million. Like, how many houses? It doesn't matter. We can't even make printers fast enough if people want to buy them. So it's like it's still at that point where why don't we take advantage of the economic benefits of co-opetition? It's not just a word that you say. It's actually a phase in a market, and also sort of a cultural understanding that like we can actually move faster and better together right now. Maybe in 5-10 years it changes, but yeah, it's got to be a collective feeling. And people like Volker have not only helped your journey, it helped my journey and whatever kind of first step I'm taking, and probably so many others. So, you know, where would we be if he didn't talk to me, didn't talk to you? Every little step is adding up. So I hope that what we take away from Ian's comment here for the 85 folks in this room is, you know, be that Volker, be that person for the next one down the line, whether it's an intern, a student, or even an investor who's looking into the space.
The number I gave, 11 million, that was Jakarta. I talked to almost the exact same member, but for the Ethiopian government, she's the Ministry of Housing, and she says she needs to build 8 million homes. So it's like everybody who's getting involved in the space is going to be very busy for the next several decades.
Absolutely. Well, ladies and gentlemen, Ian Comishin here sharing perspectives from Twente Additive Manufacturing. We really appreciate his time and insight. Big round of digital applause for the beardless version of this picture. I really appreciate everything that Ian has given to us as knowledge today. Please, Ian, drop in your contact information, how we can get a hold of you. Just can't thank you enough for your time today.